In section 3.5, we start looking at different ways to use percent. So the first one is called percent change and error. So we need to go ahead and look at a couple quick things to review from our lesson opener. First, we're just finding the absolute value. Remember, absolute value is the distance a number is from 0. So if we're going negative 10.8 spaces away from 0, distance can't be negative, so we're just going 10.8 spaces away from 0. And then 37.4 spaces from 0 is just 37.4. Find the difference between each pair of numbers. Well, the difference, we need to remember difference means to subtract. So we're just going to subtract 32 minus 78, and we get negative 46. And then we have 14.5 minus 10.9, and we get 3.6. And then last, find the average of each pair of numbers. Remember, average, you just add the numbers up and then divide by how many numbers you were adding up. So we have 259 plus 308. We'll do that first, then we'll divide by 2 because we had two numbers. We get 283.5. Same thing here, we're adding 4.2 plus 1.67 and dividing by 2 to get the average, and we have 2.935. So, for this lesson, we need to know about percent change, and there is a formula for it, so go ahead and write it down. It's important to know percent change equals the amount of change divided by the original amount, and then we have to multiply it by 100% so that we can give our answer as a percent. So example 1 says, a baker decides to raise the price of a loaf of his specialty bread from $3 to $4. This new price resulted in a large drop in sales, so he reduced the price back to $3. Determine both the percent increase and percent decrease in the price of bread during these changes. So first one, he increased the bread, or the price of the bread. So he increased from 3 to 4, which was a $1 increase. So we're going to have a percent increase of 1 over 3. 1 was the amount of change. The original amount was 3. So we'll just do 1 divided by 3, multiply it by 100%, and that's approximately 33%. Then he decided to decrease it from $4 to $3. So that's a 1% or $1 decrease. So this time we have a percent decrease. Our change amount was 1, and the original amount here was 4. We have 1 over 4, or 1 divided by 4 times 100%, and we get, it was a 25% decrease. Example 2 says, last year 1,056 people voted in the city election. This year only 912 voted. Find the percent decrease to the nearest tenth of a percent in votes cast. So we're rounding to the nearest tenth of a percent. We know, first of all, the amount change was 1,056 last year and 912 this year, gives us a change of 144. It's a decrease of 144. So we have the amount of change, 144, over the original amount, which was 1,056, which will give us our percent decrease. We multiply by 100% after we've divided those out, and we get approximately 13.6% decrease, which tells us that 13.6% fewer votes were cast this year than last year. So increases and decreases. In general, an increase of X% implies that the new amount is 100 plus X% of the original, because think about it. If you have $5 and you're increasing it by a percent, you have to have the $5, or your 100%, plus the increase. The decrease of X% implies that the new amount is 100 minus X% of the original. So that's like saying if we were going to decrease something by 10%, instead of multiplying, let's say 100, times 10 and seeing that that's going to be a $10 decrease, and then saying, well, what's 100 minus 10 gives me $90. We could just say 100 times 100 minus 10 is 90%, which gives me $90. It's just eliminating a step in there for us. So example 3 says, if the city of Woodridge is projected to grow by 7% over the next decade, and its current population is 35,000, how many people should be planned for at the end of the next 10 years? So we have to remember that a decade is 10 years, so that's just what they're talking about. So we're saying a 7% increase over the current 35,000 population. So what we want to do, instead, we could say, well, 35,000 times 7% equals a certain number, say 2,450. And then we could go back and say, so we have to add that on, say 35,000 plus 2,450 equals 37,450. Or we could just say, well, I know I'm going to have 35,000, so that's 100% right there. And I'm going to increase it by 7%, so I'm going to multiply by a total of 107%. So I have n equals, or my new population equals 107%, or 1.07 times my current, which is 35,000. And when we multiply, we get 37,450. So the city should plan for a population of 37,450. And you'll see that's the same number we got here. It's just eliminated that extra step for us. Example 4. Through dedicated training, a runner was able to decrease his time in the marathon by 13% to a time of 2 hours 47 minutes. What was his time previously? So we know that his current time is 167 minutes. Instead of multiplying by 13% for the decrease, because then we have to multiply a number times 13% and then go back and subtract that number that we got to get our answer, all we have to do is say, well, 100% minus 13% equals 87%. So I'm going to multiply by 87%. Then we need to remember our percent equation from yesterday. So we said that percent times whole equals our part. And we know that our part is 167. That's our new decreased time. We have a percent of 87%. And we're saying, well, what was our time before we had this 13% decrease? So our equation looks like this. 167 equals 87%, or 0.87 times what number? So then we'll just solve. Remember, to solve, we're dividing each side by 0.87. And we get approximately 192 minutes. So his previous time was 192 minutes. Now remember, we can always go back and check this. We can say 192 minutes times 0.87, or times 87%, equals 167, and it checks out. We could even go so far to do 192 times 13%, get the amount of our discount, or amount of our decrease, then take 192 minus our decrease, and get our 167. Either way, it's going to check out for us, so always go back and check your work. So that was percent change. We also need to talk about percent error, and here is the equation for that. It looks big, but it's not too bad, I promise. So we have the absolute value of the experimental value minus the known value, all divided by the known value. And then we multiply it by 100% to turn it into a percent. So the numerator inside the bars is sometimes called the experimental error. So you might want to label that the experimental error. And that's all of this right here. Experimental value minus the known value is the experimental error. So for example 5, it says in chemistry class, Jonah determines the density of copper to be 8.83 grams per centimeter cubed, while the acceptable value for copper's density near room temperature is 8.96 grams per centimeter cubed. Determine both Jonah's experimental error and his percent error. So the first thing we need to do is find his experimental error. So remember we said experimental error is the experimental value minus the known. And our experimental value here is 8.83 grams per centimeter cubed. Our known value is 8.96 grams per centimeter cubed. So we're just going to subtract. First off, we have 8.83 for our experimental value minus 8.96 for our known value, and that gives us an experimental error of negative 0.13 grams per centimeter cubed. Then for our percent error, remember we take the absolute value of this, that's the top of our equation, the numerator in our equation, and then we divide it by our known value. So we use that known value twice here. We use it first when we're subtracting in the top, and then we divide by that again. So we divide by this, we multiply by 100%. First of all, remember absolute value of negative 13 hundredths is 13 hundredths. Then we divide, multiply by our 100%, and we get approximately 1.5%. And last but not least is percent difference. So for percent difference, this is our equation. The absolute value of the first value minus the second value divided by the average of the values times 100%. So this formula is helpful if you do not have to know, if you do not have a known value to compare the results to. So for example 6, it says Suzanne is asked to determine the volume of a cylinder. Using water displacement, she arrives at an answer of 15.64 centimeters cubed. Then she measures the cylinder's dimensions and calculates a volume of 14.01 centimeters cubed. Find the percent difference of her results. So first we have to find the average of the values. So it's given to us here in the example. To find that average, we would have just taken the first value, which was 15.64, plus the second value, which was 14.01, and divided by 2. And we get this, 14.825. That's the average. So then we go back to these values. We have our first value, 15.64, minus our second value, which is 14.01. Because we're taking the absolute value of these, it doesn't matter which order you put them in, it's okay. So we subtract, we get 1.63. Had you put them the other way around, you would have got negative 1.63. But we're taking the absolute value, so the absolute value of this would be just 1.63 divided by our 14.825, which is our average that we got up here. Then we'll just multiply by 100% to write it as a percent. We get approximately 11% for our percent difference. Now I know that might seem like a lot, there were a lot of different formulas, but as long as you have your formulas and everything's labeled in them nice and neat, you can refer back to them as much as you need to, and of course you'll be able to use those on a note card for the test. So just pay attention to what each section is actually asking for and use the correct formula, and you should be just fine. But of course let me know if you have any questions.